everyone, I'm Dr. Uddin from College of Pharmacy, Mercer University, and we are going to do a series of pharmacy compounding skill labs, and I have with me.
Hi everyone, I'm Haley. I am a PharmD and Master's of Pharmaceutical Science student here at Mercer.
So what are we going to do today, Haley?
Yes, today we'll be going over Aliquot method and geometric dilution.
So today we'll go over the Aliquot method, and to understand the Aliquot method, first I have to describe what is MAWQ. So MAWQ stands for minimum accurately weighable quantity, MAWQ. So this means the minimum weight required for a balance. I give you one daily life example really quick. Like you have a scale at your home that you stand there and you know the weight of yourself, like the 50 kg or something. But if you put a piece of paper over there, you never see any weight. Why? Because that doesn't have the weight enough to see in the reading. So this is the minimum accurately weighable quantity. This happens same to the torsion balance or prescription balance and also electronic balance. So for the torsion balance or the prescription balance, the minimum weighable quantity is 120 milligrams. That means less than that you cannot weigh. But say like your prescription says you have to weigh 5 milligrams of the weight. So how are you going to do that? So then Aliquot word comes. So Aliquot means taking a portion. So what you have to do, you will take 5 milligram, you will take more than 5 milligram or more than MAWQ amount, which is like 120. So you take that amount of the drug and mix with a neutral compound. In this case, we will use the lactose. So lactose is commonly used as an excipient and this is very neutral. So then you mix this amount and you take a portion out from that mixture that should have your 5 milligram of the drug. So that is the Aliquot method.
So you're probably wondering, what exactly do we use Aliquot method for? Well, imagine this scenario. Let's say you are working in a compounding pharmacy and a prescription requires you weigh out 5 milligrams of a particular drug. However, your class 3 torsion balance has a minimum accurately weighable quantity, or MAWQ, of 120 milligrams. This means that you cannot measure less than 120 milligrams accurately. So how are you going to measure out your 5 milligrams? Aliquot method allows us to do so. There are two methods for utilizing Aliquot method. That includes factor method and the ratio and proportion method. For this video, we will focus on ratio and proportion method, which can be used for both solid and liquid mixtures. So the proportion method is set up as so. On the top of both of these fractions, we have drug. On the left, we have the amount of drug needed. This would be our prescribed amount, or 5 milligrams in this case. On the right, this is the total amount of drug weighed. So remember, this must be greater than or equal to 120 milligrams. On the bottom, we look at mixture. So on the left, we have the aliquot of the total mixture containing the drug amount needed. So that is the amount of mixture that will contain 5 milligrams. And this also must be equal to or greater than 120 milligrams. And on the bottom over here, on the right, this is the total amount of mixture. This is the number we are trying to calculate. So you may be wondering, what do I mean by mixture? By mixture, I am referring to our drug plus our filler, which in this case will be lactose. So let's set up our proportion. As we said, the amount of drug needed in this case is 5 milligrams. The amount of drug weighed has to be greater than or equal to 120. Let's just use 120. The aliquot of our mixture containing 5 milligrams, this is the amount we are going to weigh out that will have 5 milligrams. Let's say 130. Again, this has to be greater than or equal to 120. And then we are left to find out X, the total amount of mixture we need to make. So then we will cross multiply in order to solve for X. So that leaves us with 120 times 130 over 5. So our X equals 3,120 milligrams. That is the amount of total mixture we need. However, we know that 120 milligrams of this is the drug. So, to determine the amount of lactose we need, we simply subtract the amount of drug we weighed. So you will combine 3,000 milligrams of lactose, our filler, with 120 milligrams of drug via geometric dilution, which we will go over later, in order to create an aliquot method. We will then take 130 milligram aliquot of that mixture, and that will contain 5 milligrams of drug. In your pharmacy compounding lab, you always mix two solids together with geometric dilution. To do this, you will need a couple of items. You will need your compounding slab, a sheet of wax paper, your spatula, your weighed drug. So for this sake, we're saying this is 5 milligrams of drug, and then your weighed amount of filler, or in this case, 3,000 milligrams of lactose. So you never put anything directly on your compounding slab. Instead, you will take your wax paper and fold it underneath the slab to keep it in place. Once your wax paper is secured, you take your small portion of drug and put it on one side. And then your filler and put it on the other side. You will then visually approximate an equal amount of filler to your drug amount and slide it over to mix with. You will just repeat this motion in a couple different directions until you believe that you've mixed it pretty well. And then you will repeat this step. Again, seeing about how much you have over here and sliding an equal amount from your filler slide. Once you have added all of your filler and properly mixed, you are done. Now that we have gone over how to complete Aliquot method using solid mixtures, we will now discuss how to use liquid solutions.
Great.
So the proportion is set up very similarly as it is in solids. So again, on the top, we are focusing on drug. So on the left-hand side, it's the amount of drug prescribed or needed. In this case, it's 8 milligrams. And then on the right-hand side is the total amount of drug weighed. Remember, this must be equal to or greater than our MAWQ, our 120 milligrams. On the bottom, we are concerned with solution. So on the left, we are looking at the aliquot of solution that we want to take out containing the drug needed. And then on the right, it is the total volume of our solution. This is, again, what we are calculating. So as we said, the amount of drug needed is 8 milligrams in this case. The amount of drug we are going to weigh, we're going to say is 120 milligrams. The aliquot of solution we want to contain 8 milligrams, we can say is 2 milliliters, and then that will set us up to find out the total volume of solution we will need to make. So again, you will cross multiply, giving us 120 times 2 over 8. That leaves us with a total volume solution of 30 milliliters. Unlike with solid mixtures, we do not use geometric dilution for liquids. Instead, you just take your weighed amount of drug, and again, in this case, it's 120 milligrams, and you can add it to a beaker. You will then take your solvent and add it to the fill line of the total volume needed. In this case, it was 30 milliliters. And then you'll just mix those two together. Now that you have mixed your total volume of solution, you can take the 2 milliliter aliquot we measured out, and this will contain the 8 milligrams of drug.